Hello everyone. Today's topic is cycloidal curves from engineering graphics. Already I have discussed about this topic in my previous sessions, but today I'm going to explain or construct the curves by using a software called AutoCAD. This is how the window look like. Before my construction, let me explain the basics of cycloidal curves. Now this cycloidal curve I'm going to draw by using a software called AutoCAD, which is drafting tool, which we call it as a 2D drafting tool. Okay, where by using this tool, the civil people they try to draw the layouts of any building or any structure. Followed by this is used in HVAC also, HVAC industry, heat ventilation and air conditioning. Other than that, coming to mechanical, to draw any gear or any other component related to machines, that can also be drafted using AutoCAD with all the required dimensions. Now coming to the topic, what is a cycloidal curve? A circle with a reference point rolling upon a linear line without slipping and making a mark at every instance. By joining all those marks will give you a cycloidal curve. And now how to divide this circle into number of parts to get these many instances, how to divide this line, all these I'm going to explain. Already we have seen the conventional representation in my previous video lectures. The advantage of using any software is we don't even miss point not one distance also, we don't miss even 1 degree of angle also by using a tool, where when you draw conventionally there might be some error in your drafter measurements, or there might be a problem with your scale, okay, while taking the measurements with your compasses or while measuring with the protractor and all other drawing instruments. So all those can be avoided. You can easily place the intersection points, make the divisions properly without any point not 1% deviation, without any that kind of deviations. That is the main advantage. Now how to know? Now the only the circle diameter or the radius will be given to you. For example, if I'll say uh, d is equal to some 50 mm, then accordingly draw the cycloidal curve. Then what would I say? You have to calculate what is the circumference of the circle. What is 2 pi r or pi d? 2 pi r is equal to 2 into 3.14 into 25, okay, which will give you a length of 157. So the overall length should be 157, where the reference point will come and meet the end point at a distance of 157. Okay, by considering these two values, 50 and 157, let us construct by using a tool called AutoCAD. Here, this is how the window look like with all the sketch tools and the measuring tools and the layers, followed by line thicknesses, colors, everything. Okay, the idea is not to give you a clear picture or understanding of AutoCAD. The idea is to show you how to construct the curve cycloid. Okay, now I would like to draw a circle of 50 mm diameter that you can take from here, or else you can click with the help of a cursor, or else you can say C enter. Okay, now once you enter C enter, it will ask you specify center point of the circle. I'm specifying, randomly picking somewhere in the window. Okay, whether you want, now here you could see the measurement, it is asking you the radius. Okay, we have taken a diameter of 50. Now you can give a 25 as the radius, or else you can click on diameter, directly you can enter 50 also, that is also possible. Now you can enter 25, enter. Now this is circle of 50 diameter. Okay, now I would like to draw a line tangent to this particular circle, which is of length 157, that I can draw by picking a line with the help of a cursor, or else I'll say L enter from the command prompt. I would like to specify the first point, then I'll show the direction, then I'll enter a number called 157 because that is the circumference of this circle, then say enter. This is the overall length. Then the height, I'll go up to a overall whatever the diameter given, which is 50. Alright, then I escape. Alright, now I would like to divide this particular line into number of segments, because as I explained in my theoretical part, like we have to make number of instances. To get those number of instances, it all depends on the number of divisions you make on this horizontal line or the circumference line. Okay, you can make 4 divisions, 6, 8 or 12 divisions. It all depending on the person who is constructing. Okay, if you divide more, then it becomes easy for us to join with a free hand. All right, so you get more smooth curve. So I'm going to divide it into 12 parts. All right, or else 8 parts. So let me draw a line starting at this point, okay, at the tangential point till the center. I have drawn a simple one small vertical which is of radius 25. Let me change the color. These are all the flexibilities we have uh, if you use the tool. Let me select the line and change the color of the line, green color. Okay, I'm changing it to green color because I want to divide the complete circle into 8 parts. For that case, I'll select this line, then I'll say array. Okay, array. Then I'll select polar, then I'll select the center point. Okay, because I have selected that green line first, it has given me number of copies of that particular green line. Now the copies are only 6 here, you could see. I would like to maintain 8. Okay, now I got whatever the number of parts I would like to make. If you want, you can make it 12 also. Alright, but I just want to make it 8. Alright, let me say okay to that. If you divide the circle into 8, divide this line also into 8 parts. Okay, for that you have one option or command called division of a line. Division, enter, select the line. I want to make it to 8 parts, enter. Okay, so this is also divided into some 8 parts. Now at every instance I would like to draw a horizontal line, okay, parallel to the baseline. So for that, what I do, select the line, say offset, enter. And when you say offset, you have 3 options. You can go with through offset. Okay, here 1, select 2, select 3. This is how you can place. Okay, and if you want to extend, you can extend till the end by using a command called ex double enter. Okay, you can extend this one, and even, okay, I've forgotten to place 1. Select, go enter, select through. By right clicking it, select the first intersection, escape, ex double enter to extend this particular line. This is how it is going to be the construction, which I have explained it before. Okay, so if you want, you can give the notations also. I'll say text, specify, and whatever the height you want. Let me take text, enter, specify the point, and I want a height of 3. 3 is already specified, height of 3 is already specified, so let me say enter. and give it as P. The rotation angle 0, there is no rotation. Let me enter P point. That I'll try to keep it in. Okay. Let me select. And M enter to move to the reference point position. Alright. Then the same point I would like to copy. Select, Control C, here, second one. Just for your understanding purpose, I'm trying to place, and I'll try to edit the same. Okay. Now, text, I'll go with text edit. Okay. I'll select this one. I'll name it as 1. Select, one, then second one, 2, third one. Because the cycle will roll in right direction, so I'm going to pick one by one. Okay, I'm going to give numbering something of this kind. Unless I give the number, you get confused, so that is the reason I'm spending some time upon this numbering. Now the P acts as 8th number again. Alright. Now why I took this as 1, because this intersection is 1, because the circle is going to rotate to the right direction to travel up to a distance of 2 pi r. If that is the case, this is the first point, second, third, accordingly it will travel. Alright. Now at every intersection, what we'll try to do, we'll try to take the vertical line to mark a position called C1, C2, C2, C3, C4, C5. So for that case, what I'll do, I'll select this line. Again, in spite of making the divisions here on the baseline, I would like to make divisions here on the, what you call, center line, okay, of 8 parts. Okay, these intersections are only just for your understanding purpose, because when you draw conventionally, you try to divide the baseline into that many number of parts. Either it could be 8 or 12. But here, when you deal with software, no need to divide the baseline. You can directly divide this particular center line. All right. Now let me call this as C. This as C. Accordingly, I'll select this, copy, Control C, Control V. I'll place a point here, Control V. One more point, Control V here. Something of this kind. Okay. But this becomes somewhat clumsy. Now this point I just move near to somewhere here, and I just name it as text edit. I'll go with text edit. Select this one. I'll name it as C. This one I'll name it as C1, C2, C3, C4, C5, C6, C7, C7. Then finally here you get C8. Alright, at this point. That we'll see. Now this is how we construct conventionally. Now when this particular circle shift to the C1 position, let us see what happens. Select M, enter to move, hold center with cursor, place it at the C1 position. When you place it at the C1 position, the circle is passing through the first line, one line somewhere. Here you got an intersection. Let us take a point there, PO enter, wherever you got an intersection there. I'll try to change the color of this to maybe I'll take it as blue. Alright, now it is fine. Okay, let the same circle is moving to the next position called C2. Just have a look. It is cutting the point somewhere here. Let me take one point, PO enter. This is the next point. Alright, now the same circle moving to the next C3 position. What is the instance it is going to make? On C3 line, PO enter. This is the intersection. Okay, similarly the circle I'm moving to the next C4 point, then it is making a point tangentially here. Alright, next the same circle, when it moves to the next instance, circle, move, enter, select the center of circle, move it to the next point. Here till now, till the fourth point, whatever the intersection, it will make to the left side of the center. Left side of the center are 1 2 3 till 4. Next, now we need to take the intersection to the right side of with respect to the center. PO enter. This is the intersection. Again I'm trying to move the circle. M enter. Hold the center, then move it to C6. Okay, then it is all here, it is making a point, PO enter. This is that point. Alright, again select the circle, M enter, holding the center and moving it to 7th point. Alright, now where it is making intersection, PO enter at this point. Alright, similarly again I'm selecting the circle, M enter, at this point. Now you got a point exactly at a distance of what? 2 pi r. Now I'm taking back the circle to its original position. This circle when travels from the actual position till the distance of 2 pi r, this is how the number of instances are formed. Okay, now I'll try to join all the instances by using a command called spline. Spline, SPL is the command. Here you got a spline, enter, select one by one. This is the, okay, it is not in content, but still I'll try to, first point, then second point, third instance, fourth one, this is the next point, whatever the point. Now when you draw conventionally, you try to join all these points with a free hand. Alright, whereas as I'm using a tool, software, simply what I can do, I can join something like this, then I'll say enter. Okay, this is how the curve look like. Alright, now if you want, now how we can cross verify whether the curve drawn is right wrong means here the curve will never go after this particular vertical, it will start before the vertical only. This is how the curve look like. Let me select the curve and change the thickness, then you understand. Thickness of the curve, it is a continuous one. Yes, let me change the color. This is how the curve look like. Let us this is how the construction is made actually. This is how a construction is made. Okay, in by using a software it becomes very easy to construct, where I can divide the circle or the linear member into number of segments. Accordingly I can draw the curve. Okay, but when you are at C1, you are supposed to cut the first line only, C2 second line, C3 third line. Similarly, if it is an epicycloid, when you are at C1 you are supposed to cut C1 curve only. Okay, because here you should understand one thing, this line C1 or the first line is meant for both cases like 1 and 7, second line for 2 and 6, third for 3 and 5. Okay, if 1 is cutting this side, 7 is going to cut the other side. Okay, so accordingly you have to mark P1, P2, P3 also. If this is P, copy paste. Here I'll put it as P1 and this as P2, then P3, P4, P5, P6, P7, P8. Okay, now if you want to edit, because all are P's only, now I would like to edit now, text edit. No, forgot, T-E-X-T, text edit, select one by one. This is P8, this is P7, this is P6, this is P5, P4. Likewise, we have to give notations. Okay, notations are very much important, whether you draw conventionally or by using a tool. Okay, unless you give or you specify the notations, the other person will not understand your idea or your intentions. That is the main problem. Okay, this is how it goes. Okay, this is how it look like completely. Let me fit it. Have a look at the sketch now. Okay, this is how a sketch look like with all the instances. I'm naming it as P1, P2, P3 till P8 and centers C1, C2, C3 till C8 followed by the number of divisions of circle. Okay, this is how the curve look like. This is all for the session. where I have tried myself to clear the doubts of a student, where how to make the intersections and all. I hope I'm clear. And if you have any queries related or suggestions, you can comment in the box given below. Thank you.